acids have a really different kind of naming system from the other compounds. So first let's talk about what an acid is. For our purposes right now, an acid has a formula that begins with an H, a hydrogen ion, or a hydrogen atom. Okay, so that would be things like HCl, H2SO4, H3PO3. Those kinds of things are acids. How do you know if you see the name? Well, then it's really easy because acid is at the end of the name. So for an acid, the main thing we have to do is look at the acid formula without the H on it. Look at the formula without the H. The H's, however many there are. Okay, so if I'm looking at HCl, I say, if I take away the H and I say, what is this anion by itself? Oh, that anion is chloride. Okay? If the anion ends in IDE, blank IDE, then my acid is going to be named hydro blank acid. So if I have chloride here, then I would have hydrochloric acid. Ooh, I left out the ick. Chloric acid. If we have HBr without the H, this would be bromide. So I would name this with the same plan, hydrobromic acid. So the ic acid and the hydro are for when you just have an ide as the anion that's with the hydrogens. Let's look at another one, H2SO4. Now, if I take off my hydrogens here, what would I have left? What anion would I have here? This anion is sulfate. If my anion ends in 8, so I have something 8, then it becomes that something ic acid. Notice there's no hydro. Hydro is back here. Back here, the hydro we have. The hydro is only for when you have a hydrogen with something that ends in ide, usually a simple ion. But down with our example, the sulfate, we have sulfate. Sulfate. And so it really ought to be sulfic acid. But this is one of the weird exceptions where sulfic acid just didn't sound right to somebody's ear, and so they named it sulfuric acid. So it keeps, instead of dropping its ending, it keeps the whole name. And that's just kind of an exception. There are exceptions, unfortunately. Now, let's look at the last example, H3PO3. We take off the hydrogens, and we look at the formula without the hydrogens. This thing is not phosphate, it's phosphite. And how do we know that? Because phosphate is PO4. So if we have one fewer oxygens than the phosphate, then it must be phosphite. So if my polyatomic ion ends in ite, something ite will become something us acid. Notice we're changing that. Instead of ic like the others, it's going to be us. So I have, and I again chose the one that is kind of odd instead of following the rule. I'm giving you the exceptions. Phosphite and it should be phosphus, but they kept the or part. Phosphorus acid. So to summarize, if you have an anion that ends in "ide," then you want to be the hydro blank ic acid. If it ends in "ate," whatever my thing is, my anion, I'm just going to have a blank ic acid, no hydro. If it ends in "ite," then I'm going to have a blank us acid. So, HCl, hydrochloric acid, H2SO4, sulfuric acid, H3PO3, phosphorus acid.